Okay, welcome to the first marathon on differential equations. Again, like previous marathons, I'll be solving about 10 questions. Let's start with the first one. It says using partial fractions, find 1 over y this. So it's just asking me to express in partial fractions, which is what is going to be the next, which is probably leading us to the next part. So let's do partial fractions quickly. This is the first case of partial fractions where you have a over y and b over 4 minus y, both linear factors in the denominator. So I get a times 4 minus y plus b times y, and 1 in the numerator. So then I can use y equals to 4, and I get 1 equals to a times 0 times 4 times b equals to 1/4. And then the second one, I take y equals to 0. So I get 1 equals to a times 4 minus 0 plus b into 0. I get a equals to 1/4. So I get 1/4 4 minus y. So integrating that, okay, that is for partial fractions. I can go on and write this as 1 over 4y and 1 over 4 minus y. Okay, that is part 1. Part 2 says given that uh, given that y equals to 1 when x equals to 0, solve the differential equation this. So dy by dx equals to y times 4 minus y. In order to solve this differential equation, I'll have to first separate the variables. Okay, so I have y on this side and I have x on this side. I have to integrate both sides for the differential equation, and I will need my partial fractions now. So I get 1 over 4y and this would integrate to x plus c. Okay, I will integrate each of these separately, or I can pull out a 1 over 4 common and say that I want to integrate 1 over y here and then 1 over 4 common, and I want to integrate 4 minus y here, dy with both x plus c. So I haven't integrated so far. This would become 1 over 4 ln y plus 1 over 4 ln 4 minus y divided by minus 1. This is the integration of 1 over f of x, where f of x is linear. So ln f of x divided by f bar of x, x plus c. Now I use whatever information is given, y equals to 1 when x equals to 0, in order to find c. So I y1, let's take this as a minus ln 3, 0 plus c. So c is minus 1/4 ln 3. Okay, that is for c. Let's plug in c, and what do I want to do for y in terms of x? So y in terms of x is my objective. Let's try to find that. I have 1/4 ln y, this is still part 2, minus 1/4 ln 4 minus y equals to x, and c is minus 1/4 ln 3. I bring everything to one side. And this becomes equals to x. Now I apply the rules of logarithms after taking 1/4 common, and this becomes 3y over 4 minus y equals to x. I can cross multiply the 4 and get ln 3y over 4 minus y equals to 4x, and then 3y over 4 minus y equals to e power 4x. And then I can say that this becomes, I'm running out of space on this one. This becomes 3y equals to 4 e power 4x minus y e power 4x. I've cross multiplied, I'm gathering the y terms now on one side. And I can factor out a y and say that the remaining will go down here. And I have this as my final answer. 3 plus y. Uh, 3 plus e power 4x. Okay. Of course, my answer is different from the one in the marking scheme. Why? Because this has an e power minus 4x, and that is absolutely fine since there's no set rule there. The marking scheme will probably say OE or equivalent, and that should absolutely work. Um, okay, then it says that state what happens to the value of y if x becomes very large and positive. Okay, let's see what happens to the value of y when e becomes large and positive. What I can simply do for the part 3 is use my calculator to plug in a very large value of x. Now a very large value of x could be anything. It could be 99999, and you could just plug it on a calculator and find out what happens. Okay, so when I plug in 9999, it unfortunately gives me a math error. What I could do is I could take a smaller value for x and then try. If I take 9, and that becomes 36 because the power is already there. The answer that the calculator gives me when I plug in x as 9, it gives me the answer 4, which is indeed the correct answer because 9999 takes you to a very large number, and since this is not being divided, it's creating a sort of a problem, and I will explain to you how to go around that problem as well. Okay, so this gives me 4. I could have also ended up with 4 in another way. I could have said that as x grows large, what I see is that numerator has one exponential term and the denominator also has one exponential terms. So what happens is that the more influential term in the numerator and the more influential term in the denominator become the only relevant terms. So the highest term impacting the numerator is 4e power 4x, and the highest term impacting the denominator is e power 4x. I can cancel these and I can get 4 out of this. Although both will be heading to infinity, that is how it would work ideally. Moving on to the next question, this says the variables x and theta satisfy this. Solve the differential equation and calculate the value of x, giving your answer correct to 3 significant figures. So I bring x plus 2 to this side, dx, and sine square 2 theta d theta, and I integrate both sides. I get ln x plus 2. Now to integrate this, I'll have to use the identity that says cos 4 theta equals to 1 minus 2 sine square 2 theta. So replacing sine square 2 theta with 1 minus cos 4 theta over 2, taking out a half common and saying that this would be integrated like this. So I get half theta minus sine 4 theta over 4 plus c. Then I can use the values that are given in the question. I have x0 and theta equals to 0. So ln 0 plus 2. So that gives me half 0 minus sine of 0 over 4 plus c. And that gives me c equals to ln 2. Now when c is ln 2, I can use this again. Ln x plus 2 equals to half theta minus sine 4 theta over 4 plus ln 2. I have to plug in theta equals to pi over 4. So ln x plus 2 equals to half pi over 4 minus sine 4 pi over 4 plus ln 2. So I get pi over 8, the sine term becomes 0, and I get plus ln 2. I think I can then put it on a calculator and say that this is e power pi over 8 plus ln 2, and x should be e power pi over 8 plus ln 2 minus 2. I think that should give me the right answer. Yep, that gives me the right answer. It gives me 0.9619, which rounds off to 0.962. Question number 3, it says the solution to a particular differential equation is this, such that xi equals to 2 and x equals to 0. The diagram shows a sketch of the graph of this solution. The graph has stationary point at A and B. Find the y coordinates of A and B, giving each coordinate. So I will need an equation in terms of y. I will first try to make y the subject, y terms on one side and the rest on the other side. I will then integrate. This is integration by recognition. I can see the differential of the denominator appearing in the numerator, so this becomes ln y cube plus 1. And for this, I'm going to use the same thing that I used for the previous question. I'm going to say that I'm going to replace cos square x with 1 plus cos 2x over 2. That gives me 2. I can pull that 2 out common and integrate the other things. Theta plus, sorry, not theta, x plus sine 2x over 2 plus c. So I get ln y cube plus 1. So x equals to 0 when y equals to 2. So ln it plus 1 is equals to ln 9. So find the y coordinates of A and B, giving each coordinate correct to one decimal place. Okay, so I have C in place. I want to find out the stationary points A and B. Now to find the stationary points, I should put dy by dx equals to 0 first. When I put that, what do I get? I get 4y cubed plus 1 cos square x. Okay, so 0. So I'm going to say that either y cubed plus 1 equals to 0 or 4 cos square x equals to 0. Y cube equals to minus 1, y is therefore equals to cube root of minus 1, y equals to minus 1. That doesn't fit because I can see that both of these are above the x-axis. I found one that is below the x-axis, but that's not relevant right now. For cos square x equals to 0, therefore cos x equals to 0. Now if you remember the cos graph, either I can do it like this. I can say that my answers will be in quadrant 1, 2, 3, 4. Why? Because 0 is neither positive nor negative. I can calculate alpha and say that cos inverse of 0 is pi over 2. So my answers should be all over. So quadrant 1 is pi over 2. Quadrant 2 is pi minus pi over 2, which is also pi over 2. Quadrant 3 is pi plus pi over 2, which is 3 pi over 2. And quadrant 4 is 2 pi minus pi over 2, which is again 3 pi over 2. So I have two x values, pi and 3 pi over 2. I will use them in my equation that I have here. I'm gonna paste that here and say that when I plug in, okay, did this say I need to make y the subject? No, it didn't. So I just need to solve for y. So 2, that's pi over 2. Pi over 2 plus sine 2 pi over 2 over 2 plus ln 9. Okay, so let's see what we get. I think we get pi plus ln 9, exponential on that, minus 1, and then a cube root of the answer. Yeah, I am getting the right answer, though I am getting 5.9 correct to one decimal place. Okay, so that's correct. What I've done is I've done y cubed plus 1 equals to exponential of the entire thing. Actually, this only becomes pi and that becomes 0. And I have ln 9 here. So I have all of this, and what I've done is then I've subtracted 1 and I've taken a cube root. Okay, I do the same thing for the other value for y. Let's move this to the left a little. And I get hmm, so I have a similar number there as well. I have 3 pi plus ln 9 exponential of the answer minus 1 and then cube root of the answer. 48.1. So both answers are correct. Moving on, this is question number 4. It says a certain curve is such that its gradient at a point xy is proportional to the xy. So I'm going to say that dy over dx is the gradient, and if you remember from your O levels, that was the proportion, and I'm going to write y. So this boils down to equals to kxy. At the point 1, 2, the gradient is 4, so that tells me that I can use that to find out the value for k, which is 2. So my dy by dx is equals to 2xy. By setting up, show that this equation is this. So I can bring 1 over y to this side, and then I can integrate ln y to x squared over 2 plus c. So I have ln y equals to x squared plus c. I can use one of the points again, ln 1 and 1 comma 2 here. So ln 2 equals to 1 squared plus c. So c is ln 2 minus 1. I have to then make y the subject. Gathering ln terms on one side. And reversing the logarithm to ex squared minus 1. Then part 2 says state the gradient of the curve at the point minus 1, 2. So I think that's relatively simple. We can just say that this is going to be 2 into minus 1 into 2. That's minus 4. There's no need for a calculation. I think that was pretty clear. Just the x coordinate is changing. And sketch the curve. So exponential curves are supposed to be upward sloping like that. Okay, I just need to know where the y-intercept would be. So for that, I'm going to plug in x equals to 0, and I'm going to say that e power minus 1 into 2 gives me 0.735. So this line is going to be at 0.735, and the rest is, as you can see, nothing different about it. You can plug in more points and sort of find out where exactly it is, but that is enough for the sketch. The variables x and theta satisfy the differential equation. So I'm going to move x terms on one side, and okay, then take this to the numerator, integrate, divided by the new power and the power of the bracket and the differential of the bracket. This becomes sec square theta. So that's a relatively simple integration. Tan theta. This 2 cancels out, so I am left with 2 root 2x plus 1 plus c here. X equals to 0 and theta equals to pi over 4, so 2 root 2 0 plus 1 equals to tan pi over 4 plus c. 2 equals to 1 plus c, c equals to 1. So solve the differential equation for x in terms of theta. So I'm going to say that this is what my expression looks like right now. It's tan theta plus 1. Tan theta plus 1 multiplied by half. Then I square both sides to get rid of tan theta plus 1 whole square. 2x plus 1. 1/4 tan theta plus 1 whole square minus 1. And when 2 gets divided, I have 1 over 8 and 1 over 2. So that's my final answer. Going on to question 6, this says that the gradient is now proportional to k times y over x root x. Curve passes through these 2 points by setting up a differential equation. Find the equation of the curve expressing y in terms of x. So let's start setting up the differential equation. So y comes here, 1 over y comes here, dy. And if I were to multiply these powers, this will become x power 3 over 2. It's going to be easier to integrate with the powers put together. So I will write ln y equals to kx power minus 3 over 2 plus 1. So the new power is minus half plus c. So ln y equals to minus 2k x power minus half plus c. I have two unknowns, so I will have a set of simultaneous equations to solve. 1 1, so ln 1 equals to minus 2k times 1 minus half plus c. So c is this comes out to be minus 2k plus c equals to 0. Let's see what the other equation gives me. Ln e minus 2 times k times 4 times minus half plus c. So 1. This gives me, I think, minus k plus c. So I have a set of simultaneous equations. I can solve them whichever way I want. I'm going to take a substitution. Let's see, is 2k. And let's see if we can get our correct answer. So k is 1 and c is therefore 2. Okay, then I have my equation again. I need to make y the subject, I think, expressing y in terms of x. So ln y equals to minus 2 times 1 times root x plus 2. So ln y equals to minus 2 over root x plus 2. Is that the correct answer? Yes, I just need an exponential. So e power minus 2 over root x plus 2. Describe what happens to y as x tends to infinity. So if um, x tends to infinity, I can again put in a large value for x and find out, but I can also do this. I can say that if this denominator is going to infinity, this fraction will eventually go down to 0, so this becomes e power 0 plus 2, so y goes to 3. So I'm going to say y approaches 3 as x grows large. X goes to infinity in this case. Oh, my bad. This was in the power, so it becomes 0 plus 2. It becomes e power 2. Y approaches e power 2. A silly mistake there. Okay, then question number 7 says the coordinates x5 of a general curve satisfy the differential equation. This, it is given that y equals to 1 when x equals to 1. Uh, and I have this separation of variables in front of me. So ln y, and I integrate this. For this, I think this is a little unusual, but that is what you need to do. So this becomes ln x minus 2x squared over 2 plus c. So when x equals to 1, y equals to 1, ln 1, ln 1, oh, 1 plus c. So c is therefore 1. So ln y equals to ln x minus x squared plus 1. I have to make y in terms of x. So I'm just going to first drag this here and tell you that this is y over x, and reversing the ln gives me e power 1 minus x squared, y equals to x e power 1 minus x squared. Question 8. In a certain chemical process, the amount of x grams of a substance present is decreasing. The rate of decrease of x is proportional to the product of x and t, x and time t seconds since the start of the reaction. Thus, x and t satisfy the differential equation below. The k is a positive constant. At the end of the reaction, when t equals to 0, x equals to 100. So I'm just going to solve this differential equations. X, k, and t, all of those variables will be there. So 1 over x dx minus kt dt. So equals to ln 100. So then I can again write this as minus kt squared over 2 plus ln 100. and obtaining a relationship between x, k, and t. So this is a perfectly fine way of writing it. I don't need to make x the subject. I don't need to edit anything else as well, and that's a perfectly fine answer. So let's just write that. Then it says 20 seconds after the start of the reaction, the amount of substance present is 90 grams. So x is 90. Find the time after the start of the reaction at which the substance presence is 15. So ln 90 minus k 20 square over 2 plus ln 100. Okay, ln 90 equals to minus 200k plus ln 100. So 200k ln 100 minus ln 90, and k is therefore divided by 200. It's a very small number actually. Okay, then I need to decide whether I want to keep that in decimals or keep that as a number. I think I'm going to keep that as a number. I'm going to say that 100 over 90, and k is therefore 1 over 200 of ln 10 over 9. Yeah. Okay, and then what do I need to find when x is 50? So ln x equals to minus 1 over 200 ln 10 over 9 t square over 2 plus ln 100. I want to find t, so I'm going to plug in ln 50 for x minus ln 100 equals to minus 1 over 200 ln 10 over 9, and let's write that as 1 over 400. It's going to be easier to calculate. T square, yeah. So ln 1 divided by 2 multiplied by 400 divided by ln 10 over 9, and a negative sign, and then I take a root. So I'm getting t square equals to 2631.525, and t is therefore equals to 51.3 seconds. Okay. Then this is the next differential equation. It says solve the differential equation for x in terms of t. T is 0, x is 0. So 1 over cos squared x dx 1 over e power 2t dt. So sec square x dx. And in order to integrate this, I'm going to bring it to the numerator and say that this is the integration is this plus c. Sec square x is simple, it integrates to tan x. Then when t is 0, x is 0. So c is half. I want to make x in terms of t. So tan x equals to e power minus 2t over minus 2 plus half. So I have tan x equals to half minus half e power minus 2t. X is therefore tan inverse of half minus half e power minus 2t. State what happens to the value of x when t becomes very large. So when t becomes large, what happens to the half stays where half is, and okay, half stays where half is, and this expression, this is actually 1 over 2 e power 2t. So imagine this becoming large, so it becomes infinity, then 1 over infinity becomes 0, so I'm left with x is equals to tan inverse of half. But also do this on a calculator and tell you that as t grows large, x approaches tan inverse of half. And it says explain why x increases as t increases. So the reasoning is here, if you look at this, dx over dt is cos square x over e power 2t. So always positive, and this is also always positive. So overall I can say that this function is always positive, therefore dx over dt, that is the gradient, is positive. Therefore, as t increases, x should also increase because it's a relationship between x and t. That, I think, brings us to the end of the marathon. I hope this was productive. Please leave your questions in the comments below, and please make sure to like and subscribe if you like this video.